Okay, find the standard form of the equation of the ellipse with the given characteristics. So we have foci, and we have major axis length of 36. Okay, so the foci and the major axis are going to be going in the same direction. So let's plot these points that they gave us. And maybe we better do this. Okay, because I see, let's say this is 8. Should we say that? Be a little bit more. How about this being 8? This will be 4. So our foci are at 0, 0, and at 0, 8. So it looks like we have a vertically oriented ellipse with the center at our center is at 0, 4. Okay. So those are the foci. Our major axis length is 36. So that means 18 in one direction and 18 in the other. Now I'm starting to wish I hadn't made my graph so big. But let's go out here and say this is 18 this way. And I'll try to be consistent. Oh boy. I guess that's 18 in that direction. It's 36 all told. So 18 plus 4 is 22. So this up here at 22. And 18 from 4 would be negative 14. All right. I guess I could believe that. And so we see that our vertices, although I know they didn't ask us for this stuff, but here we're thinking about it anyway, is 0, 22. They are 0, 22 and 0, negative 14. And of course we already know the foci. They gave us the foci. And now we just need to know B. How far out does B go? Well, this is a vertical asymptote, or a vertical ellipse, so I'm going to say it like this. I'm going to say, I've been advocating to put y first when we can. I'm going to, even though, yeah, okay. And we're adding, and why shouldn't y get to go first sometimes? It does with the hyperbola. So we'll put y first, and it gets the a. And so we're thinking, what's the formula for the foci? Well, the formula for the foci is c squared is equal to a squared minus b squared. It's always the opposite of this sign in the middle here. So let's see. We know that c, being the distance from 0 to the foci, that's 4. So we have 4 squared is equal to a squared. Oh my. That's 18 squared, because a is the distance from the center, and that's 18. And this is 4. So 18 minus b, well, that's going to be substantial. So we'll end up with b squared is equal to 18 squared minus 4 squared. And so we'll say b is equal to 18 times 18. What is that? 18 squared is 324. 324 minus 16. And so, oops, I forgot what I was doing. 308, so the square root of 308, which is, what is that? Well, it's not even, but it's 17.55. So that's B. Oh, yeah, and you know, our foci are very close together with the center compared to where the vertices are. So I suppose we're not surprised to see that we're going out a long way in the direction of the B. We'll go out this way. It's almost the same. It's almost the same. Can I make it look the same? I'll try. That's not the same. But anyway, you know, the idea being that it's almost a circle. It's almost a circle. Oh boy, not my drawing. But anyway, it's almost a circle because compared to the distance from the center of the other points, the foci are relatively close together. And when they're relatively close together, that means we're approaching a circle. So, find the standard form. Okay, fine. We'll say y minus k. What's k? K is 4, so we'll subtract. Oh, I wrote k again. Subtract 4 squared over a squared, which is 324, plus x. Oh, I don't need parentheses, do I? Because it's just going to be 0. So I'll say x squared over 308. Okay, because I might as well just go ahead and write that number because I can't get a nice square root. And that is my standard equation for this ellipse, which is almost a circle. It's getting dangerously close to being a circle. See how close these numbers are? And how close these numbers are may as well be a circle pretty soon. Pretty close.